everyone, welcome back to my YouTube channel AI Stories by Anjali. In today's video, we are going to see the scenario-based question and answers related to the last week posted questions. So let us dive deep into the video. Before going to the video, I would like to thank to all my subscribers who have subscribed to my YouTube channel and also requesting to the new watchers to please like, share and subscribe to my YouTube channel AI Stories by Anjali. Please tap the bell icon for latest notifications. So let us dive deep into the video. So in our last week, we have seen two questions related to the GenAI. So today we will see the answers for those two questions. And already I have posted two more questions in our previous week. Those who haven't watched the video, please go and check it out in my playlist. So the question that we have discussed is fine-tune BERT for sentence sentiment in the finance domain. So what is BERT? Firstly, bidirectional encoded representation of transformer. So this model is one of the LLM model. So we are using this model for identifying the sentence sentiment. So I have already discussed what is meant by sentiment. So for example, then any text, let us consider any text like any language, either it is English, Telugu, Japanese, German, etc. So everything will have the sentiment for that. For example, I have told you that congratulations, you have won the prize. So that means it's a positive sentence because it is having the encouragement. It is having the positive nature, right? So suppose I have told you like, no, you haven't got the prize. So that means it's a neutral thing. Oh my God, the match is lost. So that means it's a negative sentiment. So every text will have this sentiment. So we have to identify the sentiment in order to get this sentiment analysis for the particular sentence. So for this kind of model, what is the possible metrics? Of course, this is related to the finance domain. So the project is developed in finance domain. So what kind of metrics are possible? So this is the question that I have posted. So these are the possible metrics that you can use for evaluating such kind of models. So they are accuracy, precision, and F1 score and recall. So what is accuracy? So accuracy is nothing but the cost of false positive and false negative are maintained equal. So first you have to know about the confusion matrix in order to evaluate this. Okay. So usually the confusion matrix will have four types of things, that is true positives, true negatives, false positives and false negatives. So among these four, you have to see what exactly you can leverage the cost for each of the metric, that is either true positive, true negative, false positive and false negative. Okay, so I will say you a simple example. So true positives means your model is predicting one thing and exactly the outside guessed answer is also the same thing. Okay. True negative means your model is telling something but the outside is vice versa. False positive means your model is saying no and outside is yes. Okay. And similarly, false negative means vice versa. So basically it's like, if you know the concept of confusion matrix, you can easily evaluate this. I will make a video about the confusion matrix also, so don't worry about that. Okay. So as of now, make sure there will be four kind of things in the confusion matrix. First is true positive, true negative, false positive and false negative. If you are leveraging the cost for these four as equal, then you can say you're making everything as an equal weightage, then that is the metric that you can calculate, which is called as accuracy for that. Okay. The next thing is precision. This means it is very suitable whenever the cost of false positive is high. That means if you have FP value as more, then the precision will be calculated and that's the best metric at that time. Okay. But there will be other things that you can consider for precision, like when you can choose precision as best metric and when you can choose the accuracy as the best metric. So that will be completely based on your business domain as well as the model that you have developed. So that we will see in our later videos. Okay. So the next thing is a recall and F1 score. Okay. So make sure you have to know the formulas for these four things and also know what will be the best metric for each of the things in the particular domain. Okay, so usually for this kind of things you have to use accuracy, precision, recall and F1 score as the best metrics. Okay, the next thing is neural machine translation model. So already we have seen the question for this. So neural machine translation. So what we are doing in this is we are translating the model. So we are translating the language from one language to other language. So using the sequence to sequence architecture. Okay, so that is the question. Okay, I already explained you what is sequence to sequence architecture in the last video. Please go and watch that video. So the solution for this is usually if there is any model, so I already discussed the normal general methods that you can use for evaluating the LLMs, right? So this will be useful like human evaluation. So human evaluation means, so whatever it is, so what your expected answer, what exactly the humans can play in that situation. So that you will use, like you will take a group of people, like three people and give them like some practice and ask them to evaluate, like ask them to play with your product and then use. Okay, and the next thing is NIST metric, which is based on the blue metric. Okay, so this NIST metric is same like blue metric, which you already discussed it. But here in the blue metric, it will just have an equal weight, like they assign the equal weight for each of the engram, but here they won't have like that, like they will take a particular engram and they can evaluate for each of the engrams. So that's the basic difference between NSIT as well as the blue metric. Okay, so all the formulas and all the things I will make one video in our machine learning series so that you can easily understand. But as of now, make sure like NIST also is one of the best metric which is based on the blue metric. Okay, so that can be useful for this particular model. Okay, next, word error rate. So what is a word error rate? So it is nothing but the number of words that differ between a piece of machine translated text and a reference translation. So basically whatever the model that is generated, like whatever the output that is generated by the model, and also whatever the reference text that you're actually referring, so it will compare the difference between those two and how many differences are there. So that error percent is called word error rate. Okay, so you simply like this, suppose you have prepared one material and you went for an exam, and after you have written the exam and whenever you see the marks, so your teacher is not giving you the full marks. So suppose for 4 marks question you got only 2.5 marks for that question. So why 2.5? You will go and ask your ma'am. So your teacher will tell that you have made these many mistakes, this is not appropriate to other content which was related to our class material. So that means that is your error percentage for that particular question. So that is called word error rate. Similarly, like whatever the output that is generated by your model, so that output is referenced to the referenced solution, and then you will calculate the error rate. So that is called word error rate, and that is also one of the best metric for this model. Okay, the next thing is LEPOR. So LEPOR. So LEPOR is one type of metric that is basically used in a combination of precision and recall, and also the modified sentenced length penalty and engram based word penalty. So this is one metric where it will take the combination of precision and recall with the modified sentence penalty. Okay, so what is sentence penalty? So penalty is nothing but something which you made wrong and you have made some charge for that, so for your mistake. So basically whenever you're evaluating the sentence for your reference solution, there will be some slight differences or some errors which are generated by the LLMs or something. So that how much error percentage, so for that we'll have a penalty. So that penalty in the combination of the precision and recall metric which you evaluate for this model, so those combinations, so you will add those things or you will do some calculations based on your thing. Usually they will add or calculate some percentage, so that is called LEPOR rate. So that you can use for evaluating this kind of models. Okay, so for neural machine translation model you can use precision, recall, or a combination of this. which is called LEPOR, and then NIST, which is based on the blue score, and word error rate, and human evolution. Of course, you can use your own metrics too, but these are the best possible evolution metrics for this model. Okay, so today we have seen those two answers which were discussed for the last week questions. One is fine-tuned BERT model, and then neural machine translation model. I hope you understand this video. If you have any doubts, please comment in the comment section. So these questions are very useful for cracking the generative AI interviews, because these are based on scenario questions. So please be prepared if you are going to attend the any Gen AI based interviews. So please subscribe to my channel. I hope you understand this video. So we'll meet in the next week videos. Thank you so much.